We discuss renewable energy resources series. My lecture is 5. Now we discuss about power electronics interface for solar photovoltaic. In the case of solar voltaic system, the power is generated at variable DC voltage. The power electron interface is required to convert the variable voltage into a constant grid voltage and frequency. Different kind of power converter configuration may be used for such type of application. However, DC-DC boost converter and grid interfacing inverter are two important building blocks. The DC-DC converters used to raise the DC voltage level in addition to control of SPV system incorporating MPPT control algorithms. Similarly, the grid interfacing inverter is used to inject the generated electric power in synchronism with grid voltage. Different types of integration SPV cell, standalone system, grid connected system, directly connected system via home grid, standalone system में without storage, with the storage hybrid, with the storage में appliances, small application, AC standalone system, DC standalone system, hybrid में with the stand turbine, with wind turbines, with the cogeneration system with the diesel set. स्टैंड सिस्टम में डीसी लोड एमपीपीटी कंट्रोलर, डीसी लोड एमपीपीटी चार्ज एंड कंट्रोलर, डीसी लोड बैटरी, एसपीवी सेल एमपीपीटी चार्ज कंट्रोलर, डीसी एसी कन्वर्टर, डीसी लोड ये बैटरी, एसी लोड ग्रिड कनेक्टेड सिस्टम, एसी लोड यूटिलिटी ग्रिड, हाइब्रिड सिस्टम. This block diagram shows and building block of SPV. There are two major building blocks of SPV. DC cannot perform pivot area, DC link voltage, grid interfacing inverter, grid synchronization, active reactive power and load harmonics control. Different MPPT technique. The efficiency of the solar panel is increased by the maximum power point tracking algorithm, because as the irradiation and temperature varies, the MPPT of a solar panel also varies. So maximum power is obtained from a solar array with the use of MPPT algorithm. Different MPPT techniques have been proposed in past to track the maximum power that is generated by the PV array in different environmental conditions. MPPT technique vary according to their different working algorithm, parameters and equations which are used. Several MPPT methods have been studied and researched. The following are the few MPPT techniques which have been introduced here. Among all these techniques, the most commonly used technique is hill climbing, perturbation and observation (PNO). Perturb and observe hill climbing MPPT. This is the algorithms. Input VIT, VIT means V, del P, del D, del P 0. अगर yes, then IT in it. No, del P greater than equal to अगर 0, yes, del P greater than 0, yes, तो increment V reference. And no, तो decrement. And no, 0, and no, yes, तो decrement V ref. Or no, the increment brief and then return. Incremental conductance based MPPT. This is the next algorithm. Types of DC-DC converter: non-isolated type, IGBTs, isolated type. This we use transformer. Control of DC-DC converter, we reference V, voltage regulator, current regulator, pulse width modulations, output power, voltage. This is the maximum output. Control diagrams, PV panel, DC-DC converters, grid interfacing, grid, power, logic looping, ABCD, DNQ theory, high-pass filters, hysteresis controller, proportional controller. This is the basic characteristic. IV curve and power maximum. To obtain maximum power, current control voltage is very important. Power conditioner will adjust to be most rated voltage automatically. Basic characteristic: IV current, P maximum control. Basic characteristic: estimate obtained power by IV curve. If the load has 0.05 ohm resistance, cross point of resistance character and PV character will follow it, and then power is 5 watt. Basic characteristics: my IV curve current is affected largely by change in insulation intensity. Partially shaded serial cell will produce current mismatch. Low intensity, high intensity, that is the point. Bypass diode mismatch. Case study, maximum power control. Calculate how much power you can get by following three resistors of a curve. R 0.02, 0.05, 0.10. Case study maximum. There is 50 kilowatt crystalline PV system. If surface temperature is 25 to 65, how much the capacity will be? Topologies of PV inverter: centralized string, multi-string acetyl technology, centralized inverter, PV module as series connection, then connected in parallel through string diode. Disadvantages: string converter, reduced version of the centralized inverter, single string of PV modules connected to inverter, no losses on a string diode, separate and BBT, increase the overall efficiency. AC module technology: inverter and PV module as one electrical device, no mismatch losses between PV module, optimal adjustment on BBT, high voltage amplification necessary. Future topology: multi-string inverter, AC module, AC cell, multi-string inverter. Okay, flexible, everything can be controlled individually. Now we complete my solar energy topic in this series. Thank you.